Let's have a look at this event and see if we can work out what's going on. One thing you may notice is this red dashed line here. This in fact indicates that there is some missing momentum in the event that hasn't been detected. This could be because a neutrino has been created, which is possibly interesting, but it's not what we're actually looking for in today's exercise. Apart from that, the most obvious feature is there are a lot of tracks here, and there's some yellow clusters here showing that there's been energy left in the electromagnetic calorimeter, which could come from an electron or a positron or a photon. In the Lego plot view, we can see that there are in fact two clusters of energy in the electromagnetic calorimeter. So let's try and work out what's going on. Let's zoom in a bit here. We can see that there is a cluster of energy here. If it's an electron or a positron, then there should be a track pointing towards it, because a charged particle would leave a track in the inner detector. There are a lot of tracks here, so it's quite hard to work out which one is pointing at this cluster, if any of them is. So let's go to the control window and select the Cut tab. This line here, with a tick next to it, says PT, which stands for transverse momentum. This is the momentum that's in a direction radially away from the beam pipe, not along the axis of the detector. Generally, if we're looking for something that comes from a Z or a Higgs boson that have decayed, those are quite massive particles, and the things they decay into, electrons, positrons, muons, photons, will have a lot of transverse momentum because of that, which is why we generally cut out the lower T tracks. In fact, if I untick this to show all the tracks in the event, you can see that it's even more messy. So let's re-enable that. And in fact, let's increase the threshold from 1 GeV up to, say, 5 GeV. Now that gets rid of a lot of tracks. We can still see that there is something that's pointing towards this cluster of energy. But in fact, if we zoom in further and use the M key to move down this way, there are in fact two different tracks pointing here. One of those might come from an electron, one might come from something else. Also, the fact that they're pointing towards the calorimeter cluster in this view doesn't necessarily mean it's actually pointing towards it in a three-dimensional view. One of these tracks could be in front of or behind the place where the energy has been deposited. So let's zoom in on the side view and see if that will help us work out what's going on. Again, I'm going to use the M key to move up a bit, because the electromagnetic calorimeter cluster is showing here in the side view. We can try and work out which track is which by going to the control window and selecting the finger select tool. Now, if we click on one of these tracks in the cross-section view, it gets highlighted in grey, and it's also highlighted the same track in grey in the other view. Now we can see that from two different directions it still looks as if it's lined up with the calorimeter cluster, and that's a good sign that this track probably is actually from an electron or a positron. What about the other one? Let's select the other track that looks very close in the cross-sectional view, and if we look at that in the side view, we can see that in fact it's actually pointing some way away from the energy, so that's not the one we're interested in. But let's go back to the one that's of interest. Looking at the table in the track momenta window, we can see that this is in fact a negative charge particle, so it's probably an electron, and we can flag it as an electron by clicking on the electron button at the top here, which then adds a record to this invariant mass window, which we'll come back to in a moment. Well, we found one of the electrons or positrons in this event, but it looks from the Lego plot view as if there should be two of them. Well, let's try going back to the zoom tool and zooming out a bit in this view, side view, and seeing if we can see something else. Let's move around a bit, and it looks as if at this top right corner there might be another deposit of energy, which isn't showing up in the side view because it's actually in the end part of the calorimeter and not in the barrel part. It also looks as if there is probably a track pointing towards this cluster, which is this one here. And this one, if we look at the track details, is positive, so a positron. We still click the same button here, the electron button, to mark it as an electron or positron. Let's have a look at the invariant mass window now and expand it a little bit. The program has now combined this electron and positron and calculated the invariant mass. So this is the mass that a particle would have had if it decayed into this electron and this positron and we had measured them both accurately. So the invariant mass here is 93.6 GeV. So it's a little bit above the mass of the Z boson, but we do expect to get a range of values round about 90 GeV. So it could be that this in fact does come from a Z boson decay, and either it just happens to have a slightly larger mass than usual, or there's some inaccuracy in the measurement of the tracks because nothing is ever measured with complete accuracy.